Hello everyone. In this video, we are going to see the performance of medium transmission line using nominal T method. For this method, consider per phase equivalent circuit of medium transmission line Vs sending end voltage per phase, Is sending end current per phase, load L connected at the receiving end with the voltage Vr, receiving end current per phase IR, transmission line parameters as resistance and reactance, as the circuit is divided into two parts, as we have considered here capacitance at the center of medium transmission line. Hence, the resistance and reactances are considered half value of its original value. Vc is the voltage across capacitance which is considered at the midpoint of the medium transmission line. Ic is the charging current of capacitor. Let us draw the phasor diagram for this circuit. As we are considering Vr as a reference, hence Vr is drawn at angle 0 degree. Generally, the load is of inductive in nature, hence current IR is drawn with some angle phi r. Now, if we see the current IC is passing through the capacitance, the circuit which consists of the voltage across load is Vr, hence the current through capacitance is leading by 90 degree approximately to voltage Vr. Hence, the current is drawn as shown in figure perpendicular to Vr. Similarly, we can draw current IC from this point. If we see the diagram, it is clear that if we consider the node at midpoint, hence incoming current is equal to outgoing current as Is is equal to IR plus IC. Hence, Is is the resultant of IR and IC. Hence, we can draw this as a Is. Now, the voltage drop at receiving end transmission line part is parallel to IR vector as IR into R by 2. The voltage drop due to reactance is IR into X by 2 and the resultant is IR into Z by 2. Consider the voltage drop at sending end side of the transmission line. Now, this voltage drop is due to resistance and reactance and current Is. Hence, the voltage drop across resistance is drawn parallel to Is line as Is into R by 2. The voltage drop across the reactance is Is into XL by 2. And the resultant is Is Z by 2. Now, if we see the circuit diagram, the total voltage from the source is equal to the total voltage of the circuit along with its voltage drops. Hence, the resultant can be drawn from this point as Vs. The power factor at receiving end can be considered as cos phi r. Phi r is the angle between IR and Vr. Let us consider the equations of receiving end voltage and receiving end current. As we know that we have taken Vr as a reference, hence Vr can be written as its magnitude Vr at angle 0 degree. Equation number 2. Also, IR can be calculated as IR at angle minus phi r because angle is lagging in nature. Equation number 3. Now, the current IC can be calculated as by Ohm's law, I is equal to V by R, but in case of AC circuit, I is equal to V by Z. Here, capacitance is considered, hence IC is equal to voltage across it is Vc upon minus jXc is equal to, can be written as J Vc 2 pi Fc. Equation number 4. Applying KVL to loop 2. Now, to determine the value of Vc, let us consider equation as Vc equal to Vr plus I into Z by 2 by using KVL to loop 2. Now, Vc is equal to Vr plus I into Z can be written as R plus JXL. Hence, Z by 2 becomes R by 2 plus JXL by 2. Equation number 5. Now, applying KVL to loop 1 to the figure, we can write the expression of voltage Vs is equal to Vc plus Is into Z by 2. Hence, Vs is equal to Vc plus Is into R by 2 plus JXL by 2. Equation number 6. This equation gives the value of Vs, as equation 1 and 2 gives the value of Is and Vs. Now, percentage voltage regulation, the formula can be written as Vs minus Vr upon Vr into 100. Equation number 7. Also, the percentage transmission efficiency can be calculated as the magnitude of Vr phase into Ir phase into cos phi r upon Vs phase into Is phase into cos phi s into 100. It is derived as output power upon input power into 100 to determine the transmission efficiency. Hence, from these equations we can calculate or determine the performance parameter as sending end voltage, sending end current, transmission line efficiency and percentage regulation. Thank you.